Section 10.5. So far in this chapter, we've spent the last several sections looking at various tests for determining convergence or divergence of series. We've seen the integral test. We've seen a couple different comparison tests. We've seen the alternating series test, among others. I know I'm omitting some. And in this section, we're going to see our final two tests, the ratio test and the root test. So that's going to be the main part of the section, is looking at those two tests. And then at the end, we'll also discuss some strategies for how to choose a test. So if I just give you a series and I don't strongly hint to you which one to use, we'll take a look to see what are the best choices to look at here. So let's start off by talking about the ratio test. So here's the statement of the ratio test. So we have to assume that the following limit exists. So the limit as n goes to infinity of the absolute value of the ratio of a sub n plus 1 divided by a sub n. And we're going to, so if this limit exists, we're going to call this limit rho. That's a Greek letter rho. It makes an R sound in Greek. And so there's three cases. And so if rho is less than 1, if rho is strictly less than 1, then the series here, the sum of the ANs, it converges. And note that this doesn't just say that it converges, but it converges absolutely. So that is the strongest form of convergence. If rho is strictly greater than 1, then our series, the sum of the ANs, it diverges. And if rho is equal to 1, the test is inconclusive. The series might converge, it might diverge. The ratio test won't tell us one way or another whether or not it converges. And so in those cases, we might have to use a different test if we wanted to figure out what's going on. So let's go ahead and just look at a first example in this video of how to use this. So here is a series. Does the sum from n from 1 to infinity of 2 to the n over n factorial, does this converge, does this diverge? So in this case, we have that a sub n is equal to this right here, 2 to the n over n factorial. And so we want to form the ratio of a sub n plus 1 divided by a sub n. So a sub n plus 1 is going to be, everywhere we see an n, replace it with n plus 1. So 2 to the n plus 1 divided by n plus 1 factorial. And when we do the ratio of a sub n plus 1 divided by a sub n, we end up with here 2 to the n plus 1 divided by n plus 1 factorial. All of that over 2 to the n over n factorial. So let's rewrite this fraction. We have one fraction divided by another fraction. And so when we do this, we can flip this fraction upstairs. So 2 to the n plus 1 divided by, we can also say that n plus 1 factorial, so that's multiply all the numbers from 1 up to n plus 1. So we can split off, we can peel off a factor of n plus 1. N plus 1 factorial is n plus 1 times n factorial. And this flips upstairs, so n factorial goes upstairs. 2 to the n goes downstairs. And one more cosmetic little change I'm going to make here. 2 to the n plus 1 is 2 to the n times 2. We're going to peel off a factor of 2 here. Okay, so let's see what cancels. Those n factorials cancel. Those 2 to the n's cancel. And so what are we left here with? We're left with 2 divided by n plus 1. Okay, so let's take a look and see what's going on. We want to calculate out the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. So if we put absolute values around this whole thing, well, everything in sight is going to be positive, so it's still going to be 2 divided by n plus 1. So now what do we have to do? The limit as n goes to infinity of 2 divided by n plus 1. And that is going to be, as n goes to infinity, n plus 1 goes off to infinity. And so this is going to be 0, and that's rho. So let's go back to our theorem here. So rho is 0, so that means rho is less than 1. So this says that the original series, it converges, and not only does it converge, but it converges absolutely. So does the series converge? Yes, the series, the sum from n from 1 to infinity of 2 to the n over n factorial. So it converges, and let's go ahead and say that it converges absolutely. So that's a first example of the ratio test. We'll see more examples in future videos.